Assalamualaikum and hi guys. So today we are going to do a tutorial for practical 8, that is ANOVA analysis. Okay, please refer to your practical questions, that is ANOVA analysis. Okay, let's refer to the first questions. The first question says that the following data contain 3 scores from each of 5 subjects. The 3 scores per subject are their scores on 3 trials of a memory task. And then they give you the table of the 5 subjects, that is subject A, B, C, D, and E. And the question also provide to you the 3 scores, the 3 trial score trial 1, score trial 2, and score trial 3. Now, for question 1A, compute an ANOVA. So this is very straightforward questions. So you just need to perform your ANOVA analysis. Okay, please also refer to the lecture notes 8A, that is about one-way ANOVA. Okay, so how to do the analysis for ANOVA or to compute an ANOVA? Okay, if you refer to the notes, the lecture notes AA, one-way ANOVA, they have shown to you all the steps to find the analysis, the test statistic, and the comparison for ANOVA. So now in these questions, the first step, okay, that you must count is the total for each treatment. Okay, the total for each treatment. Okay, now 1A. So 1A said that compute the ANOVA. Okay, now they give you the value of score trials and the subject. So the first step, you must get the total count for each trial. Okay, so for score trial 1, that is also referred to treatment 1. Okay, the total score is 14. Okay, and for score trial 2 or treatment 2, the total count for score trial 2 or T2 is 31. Okay, and the total score for score trial 3 or treatment 3 is 7 plus 7 plus 5 plus 7 plus 9, then you will get 35. Okay. And then if you refer also to the lecture notes, it shows you all the steps on how to do the ANOVA analysis. Okay, so now after you get all the total count for each trial or each treatment, so now you must get the value of grand total. So now the grand total, okay, Okay, the grand total. How to get the grand total? So to get the grand total, you must add all the treatment value. That means 14 plus 31 plus 35. Then you will get the grand total is equal to 80. Okay. So after you get all the the total count of each treatment, and then the grand total, you can move to the next step, that is the value of common mean. Okay, so now you can refer to the lecture notes. What is all the formula to get the, for example, the first step, we want to get the value of common mean, or CM. Okay, and then you can also refer to the lecture notes on how to get the value of SST, the total SS, and the value of SSE. Okay, now let's get the value for common mean, or CM. So what is the CM formula? So the CM formula is also referred to the grand total square divided by the total value of sample, or N. So now the grand total we got is 80. Okay, so 80 square divided by the total value of N is equal to 15. Okay, if you count, if you refer to the table, then you will get, you will see that the total subject is A until E is 5. Okay, so each treatment have 5. So we have 3 treatments. So 3 times 5, we will get 15. Okay, so when you calculate this value, you will get the value of CM, or common mean, is 426.67. Okay. And then you must get the value of SST. So how to get the value of SST? So if you refer to the formula in lecture notes 8A, so the formula to get SST is the total, or the sum of treatment square, okay, divided by the total of common mean, and then minus with CM value. Okay, now what is the value of the total treatment for each treatment? We have 14, 31, and 35. So sum of the all treatment, and then you square. So 14 square, and then you must divide by the value of total sample, that is refer to 5. Because if you refer to the table, each treatment is divided into 5 subject, that is A, B, C, D, E. So divide by 5. And then plus with the second treatment mean is 31. So 31 square divide by 5. And then plus with the last total treatment is 35. So 35 square divide by 5. And then minus with the value of CM. So the value of CM that you get here is 426.67. So minus with 426.67. So when you count all the value, you will get the SST is 49.73. Okay. So after you get the value of CM and SST, now you must also get the value of total SS. Okay. So how to get the total value of SS? So how to get the total SS? Okay, refer to the formula of ANOVA. So to get total value of SS, you must get the sum of X I G square minus C M. So how to get total of SS? Okay, if you refer to the table, we have for score trial 1, subject A, we have 4. And then subject B, for score trial 1, we have 3. And then subject C, for score trial 1, we have 2. So you must count all the values until score trial 3E, that is 9. Okay, then you square and minus with CM. Okay, so first is the score trial 1 subject A, that is 4. Then square plus, and then the subject B for score trial 1 is 3. 3 square and then plus. Next is subject C for score trial 1 is 2. So 2 square and then plus again. For subject D, score trial 1 is 1 square and then plus with subject E for score trial 1, that is 4 square. And then you continue with the next treatment, that is score trial 2 with subject A, that is 6 square. Okay, and then you continue with 7 square, 8 square, 4 square, 6 square, plus 7 square, and then plus 7 square, plus 5 square, plus 7 square, until the last value is score trial 3 with subject E, that is 9 square. Okay, and then minus with what is the value of CM that we get earlier? That is 426.67. So minus with 426.67. Okay, so please show all the value here. Okay, please show all the value. Don't put the dot. This is I only show you the how to calculate for total SS. Okay, so I put dot. But for your practical task, for your tutorial, you must complete all the value and show all the value. So please proceed to show all this value. Okay, so you must show 4 square plus 6 square plus the next is 7 square and then plus 8 square plus 4 square until 9 square. So please show all value. Show all value. Okay. Because there is a marks here. So each step have their own marks. So please show all the steps. Okay. And then when you count it, you will get 73.33. Okay. And then next, you must also get the value of SSE. So how to get SSE? If you refer to the lecture notes, 8A, the formula for ANOVA. Okay. So to get SSE, the total SS should minus with SST. So what is the value of total SS that you got? That is 73.33. So 73.33. Okay. Minus with what is the value SST? So the value SST that you that we have counted earlier, it is 49.73. Okay, so the final value for SSE is 23.6. Okay, 23.6 for SSE. Okay, now after you got all the value for SSE, as the total SS, the value for common mean CM, the value of SST, okay, you can start to convert all the value into the ANOVA table. Okay, so you must draw your table, draw the ANOVA table. Okay, the ANOVA table should have source. Okay, if you refer to the lecture notes, you can have the dummy tables for ANOVA. Okay, so that must have source, the treatment, error, and total. Okay, so you must also get the value of the F, the value of SS, and then the value of MS, and the final one is the value of F, or test statistic of F. Okay. So how to get the degree of freedom for treatment? So to get the value of degree of freedom for treatment, the K minus 1, or the treatment minus 1. So we have 3 treatments, so minus 1. So we will get the degree of freedom for treatment is 2. So how to get the degree of freedom for error? So it is N minus K. So the total value of N we have is 15. So minus with K treatment is 3. So we will get the degree of freedom for error is 12. Okay. And the total value 12 plus 2, we will get 14. So what is the value of SS? We already get the value of SS. So just convert it in this ANOVA table. So that is 70. Sorry, the value of SST. So the value of SST, okay, the value of SST is 49. Okay, 49.73. Okay, and the value of SSE is 23.6. Okay, so the total value is SST plus SSE, that is 73.33. Okay, so now you must get the value of mean square for treatment, or MST. So how to get MST? To get MST, the value of SST must divide by K minus 1. So the value is 24.87. Okay, the value of MST is 24.87. So how to get the value of MSE? So to get the value of MSE, the value of SSE divided by N minus K. So that is 1.97. Okay, now how to get the value of F, or test statistic? Okay, that is MST divided by MSE. Okay, MST divided by MSE. Okay, you must show the calculations or the equation. Okay, so you can also directly get MST, for example, 24.87, and MSE is 1.97. So you just simply divided the value, then you will get the F value, that is 12.62. However, okay, you must show the calculation or the equation on how you get this value of F, or the value of test statistic F. Okay. Okay, now we must start to state the hypothesis. Okay, so now what is the hypothesis that we can say? Okay, again, if you refer to the lecture notes, Okay, we must state it. The null hypothesis is the mu 1 is equal to mu 2 and equal to mu 3. Okay. For alternative hypothesis, we are going to say that at least one mean is different. Okay, so for null hypothesis, we are going to say that at least one mean is different. Okay, so you can refer both these, how to state the null and alternative hypothesis based on the lecture notes. Okay, so now after you stated the null hypothesis and alternative hypothesis, so you must get the critical value. So now find the critical value. So in this question, they give you the value of alpha is 0.01, isn't it? Because it said that it's referred to 0.01 because if you see for question 1b, okay, it said that test all pairwise differences between means using the Taki test at the 0.01. So same for question 1a, you must refer to the alpha level that is 0.01. Okay, so now as alpha is equal to 0.01, okay, so the value of the F or degree of freedom, okay, as we already count it and have inserted in the ANOVA table, that is referred to 2 and the other one is 12. Okay, so 2 is refer to the degree of freedom treatment and 12 is refer to degree of freedom error. Okay, so now what is the F critical? F critical or F alpha. So F critical or F alpha, okay. Okay, now you have the value of alpha 0.01 and the degree of freedom for treatment is 2 and the degree of freedom of error is 12. So you can refer to the F distribution table. So if you refer to the F distribution table, the above row, okay, is referred to the degree of freedom treatment. Okay, so in F table, distribution, okay, the value in the above here, okay, is referred to degree of freedom treatment or numerator, degree of freedom numerator. Okay, that is 2. Based on this question, that is 2. And this side will give you, okay, the value of degree of freedom for error or the denominator. Okay, so this is referred to the degree of freedom treatment or numerator. Okay, so this one is going to refer to degree of freedom of error or degree of freedom denominator. Okay, so based on this F table, you will get the F critical or alpha is referred to 6.93. Okay, so now you have the F critical value. So as I said, although in our previous calculations or in our ANOVA table, we already can simply get the value of F by divide the value of MST with MSE. But however, you must show the equation or the calculation on how to get the value of test statistic of F. Okay, so next you must show that the test statistic, okay, you stated in your practical task, test statistic, okay, test statistic that is referred to F is equal to MST divided by MSE. Okay, so please show these equations how to get the test statistic of F. Okay, so just insert the value. That is 24.87 divided by the value of MSE is 1.97. That is equal to 12.62. Okay, so now you can do the comparison. So now the test statistic F, okay, is 12.62. The value of F critical or F alpha is 6.93. So it shows that the test statistic F, that is 12.62, is greater than the F critical alpha, 6.93. So we are going to reject the null hypothesis because the F value test statistic is greater than the F critical alpha. So we can state that there is a difference in the 3 trials score. Okay. So now let's refer to 1B, question 1B. So in question 1B, okay, it said that test all pairwise differences between means using the Taki test at the 0.01 level. Okay, so for this 1B question also, actually you can refer directly to the lecture note 8A. It shows on how to do the comparison using Taki methods. Okay, so now okay, for 1B, okay, 1B. So what is the formula for Taki method? So the formula Taki method is referred to the value of omega equal to Q, alpha, and then K, F, degree of freedom, and times with S divided by square root and value. Okay, and if you refer to the formula of Taki method, okay, or Taki test, omega Q alpha times K df and times with S divided by square root n. Okay, it also shows that S should be where S is referred to square root of MSE. Okay. Okay, now, okay, you must get the value of each mean for each score trial. So for score trial 1, score trial 2, and score trial 3. Okay, now what is the total value for score trial 1? That is 14, and score trial 2 is 31. Okay, and score trial 3, the total is 35. Okay, so now for Taki methods, okay, for Taki methods or Taki test, we must get the mean value, okay, the mean for all 3 treatments. Okay, so how to get means? 14 divided by 5 because we have 5 subject, and 31 also divided by 5, and 35 also divided by 5. So now we will get the mean for score trial 1 is 2.8, and score trial 2 is 6.2, and for score trial 3 you will get 7. Okay, so please show this table. Okay, please show this table in your task. Please show all this table in your task. Okay, show also the formula for omega. Okay, all right, now you can start to calculate the value of omega. So omega is equal to Q alpha. Okay, in these questions, it refers to the alpha 0.01. 0.01, and then the value of K is equal to 3, and the value of degree of freedom is 12. Okay. So remember, if you refer to the formula and the lecture notes, we must get the value of this one first. Okay. So how to get this value? We must refer to the Taki table. Okay. So now if you refer to the Taki table with alpha 0.01 and degree of freedom is 3 and 12. Okay. you will get the value is equal to 5.05. Okay. Okay, so now omega, we already get the value of this one. Okay, the value this one is based on the alpha and the degree of freedom. And when you refer to the Taki table, you will get 5.05. So 5.05. And then you insert the value of S divided by square root N. So S is equal also to square root MSE. So what is the value of MSE? So please refer back to your ANOVA table. Okay, so the value of MSE, square root of MSE, you will get 1.40. Okay, and divide by value of square root common sample mean. So the common sample mean is 5, because each treatment have 5 subject. Okay, so now when you count each, you will get the value of omega is referred to 3.16. Okay, so now after you get the value of omega, you can start to do the comparisons. That means compare the mean differences. Okay, so now let's do the comparison. Compare mean differences. Okay, compare mean differences. So how to compare mean differences? Okay, I also show you in the lecture notes, AA. So to compare the mean differences, okay, it is more easier if you compare the means by using this method, that is comparison between mean treatment 1 and mean treatment 2, and then X bar 1 or mean treatment 1, average mean treatment 1, and compare with average mean treatment 3. And then the last comparison that we can do is X bar 2 and X bar 3. Okay, so it refers to treatment 1, comparison between mean treatment 1 and mean treatment 2, and then comparison between mean treatment 1 and mean treatment 3, and then the last one is comparison between mean treatment 2 and mean treatment 3. Okay, so now if you refer to our table, okay, our previous table, okay, we already count the value of each mean for each score trial. So that is 2.8, 6.2, and 7. So now between treatment 1, mean treatment 1 and treatment 2, so treatment 1 is treatment 1 and treatment 2. So 6.2 minus 2.8. Treatment 1 and 2. So 6.2 minus 6.2 minus 2.8. So you will get the value is 3.4. So now between treatment mean for treatment 1 and treatment 3. So 1, 2.8, 3 is 7. So 7 minus 2.8, you will get 4.2. Okay, so the last comparison is between mean treatment 2 and mean treatment 3. That means between 6.2 and 7. So 7 minus 6.2. We'll get 0.8. Okay, now the value of omega that we already count it, we get 3.16. So now we can do the comparison with the value of omega. So now 3.4 is greater than 3.16. Okay, and 4.2 is also greater than 3.16. Okay, and the value of 0.8 is less than 3.16. So now we have two comparison that has the value greater than the value of omega. So in final step, what we can say? Okay, so in final step, okay, we can say that the majority mean difference is more than omega. So the null hypothesis is rejected. So we can claim like that. Okay, we can claim that majority mean difference is more than omega. So the null hypothesis is rejected. Okay, or we can also state that we can declare a significant difference in score trials between trial 1 and trial 1 and trial 2, and between trial 1 and trial 3. Okay, so that is how we are going to get the value or the analysis for 1A and 1B. Okay, so please show all the steps, all the equations like I show you. Okay, so please also try to calculate for question number 2 and 3. The equations and all the formula and all the step is same like I show you in question 1A and 1B. Okay, so please discuss with your member groups to solve for question number 2 and question 3. Okay, so for questions 2A, okay, for question 2A, Okay. For question 2A, okay. For question 2A, the test statistic of F, okay, the test statistic of F, okay, you should get the answer is 2, 8, 3, 2, 8, 3, 5.69. Okay, so please try, discuss with your group member and try to calculate the value. But before you get the value, you show the value of test statistic of F, you must show all the equations and all the formulas like I show you in question 1A and 1B. Okay, so please try for question number 2A. And the test statistic of F, you must get the answer is 2835.69. Okay, and for the critical value of F, so F critical or F alpha should be okay. Let's in this question, okay, again in this question number 2 and question number 3. Okay, so for question number 2 and question number 3, okay, the significant alpha should be referred to 0.05. Okay, so should refer to 0.05. Okay, so for question 2A, the F critical or F alpha, okay, with alpha 0.05, then you must get the value is 3.89. Okay. Okay, for 2B, when you use the Taki test or Taki method, okay, the value of omega should be referred to 17.79. Okay, so please try. And the answer for the omega should be 17.79. Okay, and the comparison next, for the comparison, okay, for the comparison between three treatment, it should be stated that the comparison difference means all, okay, the comparison different mean all the comparison different mean have greater than 17.79. Okay, because when you do the comparison different means for question 2B, okay, all the comparison mean value is greater than the value of omega 17.79. Okay, so please try. You must get all the comparison mean greater than the value of omega. That means should be greater than 17.79. Okay. Okay, for question 3A, okay, for question 3A, okay, for question 3A, please solve and show the equations, okay, and please try. So the test statistic of F, value that you should get for question 3A is F equal to 0.86. Okay, 0.86. And the value of F critical, okay, F critical or F alpha with alpha equal to 0.05. So you must also get 3. The F critical is 3.89. Okay, and then for 3B, for test, Taki test or Taki method, the value of omega should refer to 8.46. Okay, 8.46. Okay, 8.46. And when you make the comparison, okay, between the different means, okay, it should show that all the comparison means are less than the value of omega, that is less than 8.46. So we are going also stated that we fail to reject the null hypothesis. Okay. Although I mentioned to you in the in our lecture class that if we fail to reject our null hypothesis, okay, we cannot further the Taki method or the Taki test. Okay, but in these questions, okay, let's say if you find that the F critical, the F statistic is less than the F critical, so it is not fall in rejection region, so you cannot reject the null hypothesis, or you fail to reject the null hypothesis. Although you fail to reject the null hypothesis, but in this tutorial, they want you to proceed to do the Taki test, because they want you to prove that it is rejected, okay, or we fail to reject the null hypothesis. Okay, so just show the Taki test. Okay, so that's all for tutorial practical A for ANOVA analysis. So if you have any question, you can ask me, but please discuss with your friends and refer to the lecture notes on how to complete this practical. Okay, so please complete all the practical, and it should be group work. So we have 15 groups, so must have 15 submissions in Putra Blast. Okay, so that's all. Thank you, and I wish you all the best.